I'm Ali. Today I want to talk about another interview problem. This problem is known as LPS, or longest palindromic substring. It has been asked mostly by Facebook and Amazon. So in order to understand this problem and solve it, let's first read it together.
So the problem says, given a string S, return the longest palindromic substring in S. So first of all, we should see what is a palindromic string or substring. To clarify this, consider this example, which is the Christopher Nolan's newest film. Consider word Tenet. This word is a palindrome noun because it reads the same backward and forward. So if I read that forward, it is tenet, and if I read that backward, it's also tenet. But the problem is to find the longest palindromic substring. So in order to understand this, the LPS algorithm and the LPS problem, let's consider these examples. For example, in the first example, the input is BABAD. So what is or what are our longest palindromic substrings? So we should search here for palindromic or symmetric substrings. As you can see, we have, if we choose B itself is a palindromic substring, but it's not the longest. So what about BA? No, it's not BAB. So BAB is a good one, but we should consider again BABA. And it is BABA when I read that forward, and it's ABAB when I read that backward. So it's not a good idea. So BAB could be one of our answers. And also, as you can see, ABA. It's another palindromic substring. So here we have two, ABA and BAB. These are our longest palindromic substrings because the length of both of them is 3, sorry. So let's see the second example. C again itself is a palindromic substring. CB it's not. CBB no. CBBD no. But as you can see, BB is a palindromic substring, and we cannot find any other palindromic one. So here BB is the longest palindromic substring that we have. What about this example? Here we just have A. So this string includes just one character, and this character is also a palindromic one. Because if I read that forward, it's A, and if I read that backward, it is also A. So here the longest palindromic substring would be A. And what about this example? We have AC. So as you can see, AC and CA are not equal. So we can consider A or C as our longest palindromic substring, and the length is 1. Now that we have read the problem and understood it, I want to talk about the suitable algorithm to solve this problem. There are several algorithms that we can solve this problem with, but I'm going to explain the dynamic programming approach. The dynamic programming approach has two conditions. The first one is that the str is our string, so the start and the end should be the same. I show the first condition on the string here, so consider this is my start index and this is my end index. The first condition says that in this string, if I want to find a palindromic substring or a palindromic string, and if I want to know whether a string or a substring is palindromic, I should first check the start and end characters. So for example, here the start character is A and the end character is B. So this the whole string is not palindromic because the string didn't meet the first condition. And the second one says that the non-boundary substr or substrings should also be palindrome. Here, so these characters or this substring is the non-boundary. In order to clarify this, let's take another string. So consider this is my string, and this is the start one and this is the end one. So the first condition is that these two should be the same, and here they are. And the second one says that the non-boundary, substr should also be palindrome, which means this. So as you can see, this is palindrome. So I can say that this whole string is a palindrome string. Now let's find the longest palindromic substring in this string. And for that, we are using the dynamic programming approach. In this approach, what we do is that we divide the given string into different substrings. And these substrings also have different sizes. For example, first I divide this string, which the length of this string is 8, to substrings with a length of 1. So that would be, for example, a substring, and that is another, and till the end. So it means that first I analyze each character, that whether it is a palindrome substring or not, and then I increase the size of these substrings by 1. So after I analyze the size 1 substrings, I will go and check the size 2, for example, from index 0 to 1, and 1 to 2, and 2 to 3, and so on. And remember, on each step, after incrementing, I just check the substrings, that whether they are palindrome or not. And if they are palindrome, I put 1 to the table based on the index of that substring. And if it's not palindrome, I put 0 on the table. So it means that this table is a Boolean type table. Now let's fill out the table. So the first step is to divide this string into, as I said before, into size 1 substrings. So I will analyze each character and see whether it's palindrome or not. So this means I want to analyze from index 0 to 0. So I'm here now. And as each character is palindrome itself, because it reads the same in both ways. If I read that from here, it's A, and if I read that backward, it's also A. So all of these size 1 substrings are 1. So that means that this diagonal is 1. This diagonal in the table is all 1. So remember, 0, 0 means I'm going from 0 to 0. 1, 1, it means that I'm going from 1 to 1, and 2, 2, and so on. Then I go to the, then I divide these string into substrings with size 2. So now I want to analyze these substrings and see whether they are palindrome or not. So first I want to analyze 0 to 1, as you can see here. So here, so 0 to 1 on the table is here, and then I will analyze 1 to 2, 1 to 2. So as you can see, I again go diagonally in the table and analyze each of those substrings. So the value of 0, 1 in the table is 1, because as you can see, it's palindrome, and 1, 2 is 0, because AB is not palindrome. And let me just clear here because we want to analyze the other one. And then we have 2, 3. So 2, 3 is here. And as you can see, it's not, again, palindrome. So I put 0. Then we have 3, 4. 3, 4, it's palindrome. I put 1. 4, 5, not palindrome. So 0. 5, 6. 5, 6, not palindrome. Again, 0. And finally 6, 7, 0 again. So I went through the length 2 substrings with this diagonal, and on the next part I will analyze length 3 substrings. So for example, 0 to 2, 1 to 3, and so on. Okay, before that I again clear here. Okay, so 0 to 2. Now as you can see, we have more than 2 characters, so just comparing the boundary substrings or characters here is not enough, and we should go to the we should also check the second condition. So these 2 conditions both applies to strings with length more than or equal to 3. Because when we have 2 characters in our substring, the second condition cannot be applied. Okay, so first of all, I check the boundary strings or substrings, so A and B, and because they are not equal, so it's not palindrome, and I put 0 here. Then we have A to C, ABC. As you can see, the boundary characters are not equal, so 0 again. And then 2 to 4, the boundaries are not the same, so again 0. And then 3 to 5, 3 to 5, the boundaries are C and B, so again 0. And then we have 4 to 6, C and A, so again 0, they're not equal. And 5 to 7, B, A, B. So as you can see, the boundaries are the same, and they are both B. Now we should check the non-boundary substring, and it should also be palindrome. So the non-boundary is A, and as it's single character, it's a palindrome. But we should look it up in the table. So this index is 6, 6. So when we look up here, 6, 6 is here, so it's 1. So we understand that the substr is also a palindrome. Then it means that this substring is palindrome. And on the next part, I will check substrings with length 4. So I'll go through 0, 3, 1, 4, and so on. So 0 to 3. Okay, boundary substrs are not the same. So it's 0. Then 1 to 4, they are not the same. A and C, again 0. 2 to 5. So as you can see, the boundaries are the same. Both of them are B. And now we have to check the non-boundary substring, which is here. So we check here. In other words, we can write also this condition in this format, and it will help us in writing the code. So consider TB is the 2D array that I store this table in it. And oops, I wrote that, yeah, so ugly, so I write it again. Yeah, TB is the array that we have. So this means the non-boundary substring should be palindrome, means that TBI plus 1, and I mean this index. So consider, for example, this example, this is I and this is J. So TBI plus 1, J minus 1, which means I plus 1 and J minus 1, that in the table, for example, for this index to 5 that we are talking about, it will be what? Yeah, I plus 1, which is 3, and J minus 1. So I should look into the 3, 4. So this index, when I want to fill out this index, I should look at this cell on the table, and it should be equal to 1, and that means that that substring is also a palindromic substring. Okay, back to our problem. So this string index, this substring I should say, from 2 to 5, the boundary characters are the same, and now we should check the non-boundaries. So we have to check 3, 4, and as you can see, 3, 4 value is 1. So it means that this substring is palindrome, and we put 1 here. Then we go through 3, 6. So let me just make some space here. So now you know what is I and J, and yeah, let me also clear them. So yeah, oops, yeah, okay. So we want to analyze 3 to 6 now. So boundary characters are not the same. We don't check non-boundaries anymore, and it's not palindrome. Then we have 4 to 7. Boundaries again are not the same, so it's not palindrome. Then we have to check substrings with length 5, I think, right? Yeah, 0 to 4, 1 to 5. So let's check them. 0 to 4. Okay, boundary characters are A and C. They're not the same. So on this cell for 0, 4 index, we put 0. Then we have 1 to 5. Yeah, sorry, they just merged with each other. So 1 to 5, the boundaries are not the same. Again, 0. Then we have 2 to 6, which is here. And as you can see, boundary characters are not the same. Again, 0. And then we have 3 to 7. So C and B are not the same. And again, we have 0. Again, I clear here for the next round. And now we have to check substrings with length 6. So 0 to 5, 1 to 6, and so on. So 0 to 5. Yeah, boundaries are not the same again, as you can see. So it's 0. Yeah, consider this is 0. And then we have 1 to 6. Oh, boundaries are the same, thankfully. So boundaries are both A. Then we'll look into the non-boundary substring, which is BCCB here. And that means we have to look up in the table from index 2 to 5. So we look here, 2 to 5 is 1. And yeah, I'm using this formula, okay? This mathematical equation here. So 2 to 5 is 1. Then I can say 1 to 6 is also 1, and it's palindrome because, yeah, the boundaries are the same, and the non-boundary substring is also palindrome. Then we have to go through and check 2 to 7. The boundaries are the same again. So let me first erase here so you don't confuse yourself. Yeah. So boundaries are the same. And again, we go to the non-boundary substr. So it means that we should check 3, 6 index in the table. 3, 6 is 0, so it's not palindrome, and we put 0 here. Okay. Again, sorry, sometimes hard. Yeah, finally. And yeah. Then we have to check 0 to 6, so strings with length 7. So 0 to 6. So boundaries are the same. They are both A. And we have to check the non-boundary substr. Yeah, because always remember this equation. So we check 1 to 5. Index 1 to 5 in our table. 1 to 5 is 0, so it's not palindrome. So 0 to 6 is not palindrome. And then we have 1 to 7. As you can see, the boundary characters or substrings are not the same, so we don't check the non-boundary part, and it's 0. And then we have the whole string. Let me again erase here. So we have the whole string 0 to 7. So as you can see, boundaries are not the same, so it's not palindrome, and we don't check the non-boundary, so it's 0. And the problem is to return the LPS or longest palindromic substring, and we can find it out easily with a simple look at the table. So these are strings. Remember, we started from length 1, length 2, 3, 4 until 7. So 8, because it's 0 to 7. So yeah, this guy here, this one here, is our longest palindromic substring, and we can look it up at the index. So the index is 1 to 6. So it means that my longest palindromic substring is this substring. So yeah, A, B, C, C, B, A. And if we read that backward, it's also A, B, C, C, B, A. So I hope you understood this algorithm and the way we solved this problem with. On the next part, I will talk about the suitable code and how should we turn this algorithm, this dynamic programming solution, into code. Considering the dynamic programming approach that we talked about in the last section, let's see and analyze the code. So we have a class, and in this class we have a string type method. That in this method we want to find the LPS. The input of this method is a string, and I call that input. First, I check if it's empty, so I will not check it anymore. And if not, we will go and write the rest of the code. So I have defined a variable, an integer variable called strlen, which is the length of the string, and then we have longest so far, start index, and end index, that all of them are integer variables, and I will talk about them further. And then we have our 2D array, which is our dynamic programming table, or DP table, that you can see here. And its type is Boolean, because as you may remember, each cell of this 2D array or this table can have 1 or 0 value. Then we have the nested for loop, that is the main part of this code, an algorithm. On the first loop, we just loop over j, and we set the jj cells of this table to true, and it shows the main diagonal of this table, that we just set that on the algorithm to 1, because all of them are palindrome substrings. Each character is palindrome. Then on the second for loop, we loop from I to j, and we compare character by character our string based on these two conditions that we talked about before, to find the longest palindromic substring. So the first condition of this if statement is the equality of characters. This is for the boundary characters, that it matches to our first condition, as you may remember. So we check the character at ith index and character at jth index. And also we have another condition which contains two other conditions with or. The first one is for substrings less than 3. I mean substrings that their length is less than 3. And let me show you by an example. So consider this is I and this is j. This condition means that if j minus I is equal or lower than 2, so as you can see here, j minus I is 2. This condition with the first one means that this substring is palindrome, because if this condition is true, then it means that the substring length is 3, right? Or maybe lower than 3, it's 2 or 1. And if the size of our substring is in that case, so we do not need to check the non-boundary, because we are sure that it contains just one character. So as you can see here, we just check the boundaries, and if they are equal, we are sure that it is palindrome, right? Because it's just one character. And if, for example, j is here, not here, then j minus I would be 1, and it's lower than 2 again, so it is palindrome. We just need to check the boundaries. And this condition is the second one that we had on the algorithm section 2. And it's about assuring ourselves that the non-boundary substrings are also palindrome. So if this if statement is true, then we set that cell of the table to true, which means that that string with that index is palindrome. Then we have another if statement, and in this if statement we check the current length of the string that we just set true on the table with the longest so far. Longest so far is an integer variable, and it shows the longest length of the substring that we found so far. So if it's bigger, we should update that with the new length, I mean the length of the new substring. And also we set start and end index with I and j. So finally we could return the longest palindromic substring. And at the end of this method, we just return the substring. So then we have the LPS as the result. And if you are familiar with Java string methods, you know that substring method can take 2 or 1 parameters, and if we give it 2 parameters, it will return this string, the whole string with start and end index. And the reason that I put +1 here is that the second parameter is exclusive. So if I just put end index, it would then return the last character on the result string. Then I wrote a simple test to test this function. As you can see, I just passed our example here. So let's check the result. Yeah, as you can see, the result or the LPS of this string is ABCCBA, and it's the same to the answer that we reached on the algorithm section. So let's try another string 2, for example, AABBAB, and I check these two. So the answer is ABBA, which is our LPS here. Now let's talk about the time and space complexity a bit. The time complexity of this dynamic programming solution is an order of n square, because we have a nested for loop here, and also the space complexity is again an order of n square, because we have to save the whole to the array in our memory.
I hope this video helped you to understand this important interview problem. Also, if you like this video, please consider subscribing and sharing it with your friends so we can help more software engineers to be prepared for their interviews.